Chapter 1, Exercise 11. Consider the cases z equals 0 and z doesn't equal 0 separately. For z doesn't equal 0, choose r equals absolute value z and w equals z over r, and show that r and w satisfy the conditions of the exercise. First, suppose that z doesn't equal 0 and set r equals absolute value z. Then r greater than 0 by theorem 133. Also let w equal z over r. Then z equals r times z over r equals rw, and using theorem 133, absolute value w ultimately equals 1, since 1 over r greater than 0, proposition 118e. Now assume that there exists another pair r prime w prime such that r prime greater than 0, absolute value w prime equals 1, and z equals r prime w prime. Then rw equals r prime w prime, and so by theorem 133 we have this. Thus r equals r prime. From rw equals r prime w prime, it now immediately follows that w equals w prime as well. Hence, the decomposition z equals rw with r greater than 0 and absolute value w equals 1 is unique whenever z doesn't equal 0. If z equals 0, we can take r equals 0 and any w with absolute value w equals 1. From here, we conclude that the numbers r and w wouldn't be uniquely determined when z equals 0. Here is a picture. Geometrically, with polar coordinates of z equals x plus iy, note the following. So, z equals absolute value z cosine theta plus I sine theta, where theta is called the argument of z, denoted by arg z. If z equals this and v equals that are the polar forms of complex numbers z and v, then zv ultimately equals absolute value z, absolute value v, cosine theta plus phi plus I sine theta plus phi. Thus, the geometry of multiplying complex numbers is based on the following rules. Add the angles and multiply the magnitudes. Visually, this represents rotation and scaling, respectively. If z equals this is its polar form, then for any positive integer n, we have z to the n equals absolute value z to the n cosine n theta plus I sine n theta. So, w equals absolute value w cosine phi plus I sine phi is an nth root of z if and only if absolute value w to the n equals absolute value z, and theta equals n phi plus 2k pi for some integer k. Geometrically, the first nth root of z is obtained by taking in the line that makes an angle with the x-axis equal to the nth part of the angle that makes z with the x-axis, and the point that is at the distance absolute value z to the nth from the origin. Here is a picture. In the previous figure, we can see the three cubic roots of the complex number. I equals 1 cosine pi over 2 plus I sine pi over 2. Thanks for watching.